Hi everyone, this video is made for problem 2 in homework 6 for EEC150B. And the problem we are going to discuss in this video will be slightly different from the problem statement in the homework. And the problem is, an experienced engineer who has computed many FFTs of real-valued sequences xn has noticed that although many of the DFT coefficients are often complex-valued, two coefficients, namely x0 and xn divided by 2, are always real-valued when n is even and xn is real. In part A, you want to prove x0 and x500 to be real-valued when n is 1000. So from the class, you can write down the DFT, discrete Fourier transforms, in this format. And for x0, you will get the sum of xn, which are the real value sequences from n is 0 to 999. And for x500, you will get the sum of xn multiplying with a -1 to n. Both x0 and x500 are real valued because in problem statement, it has given you that xn are real value sequences. So when you sum up the real value sequences, you will still get real value sequences. So now in part B, you are given with the 4-point sequence xn equals to -4, 3, -4, 3. And it's asking you to determine its 4-point DFT sequence xk. So in the class, you have learned the DFT of the finite length signal xn is defined as xk. Now when n is 0, xn is -4, n is 1, xn is 3, and so forth. So now you can write down xk in this form, and then you can replace k with 0, 1, 2, and 3 to get the answer xk to be -2, 0, -14, and 0. And in part C, it's an inverse DFT problem. So from the class, you have learned that xn can be written down like this. By using the definition of inverse DFT, you can write down V2 with Vk equals to -1, -j, -1, and j, which is a 4-point DFT sequence. So now you have the lowercase n equals to 2 and the uppercase n equals to 4. Then you can write down V2 in this form. And by replacing Vk and k using the problem statement, you can finally get V2 equals to -2. So now, finally, we can move forward to the last part in this problem. In part D, you are given a 10-point sequence yn, and the corresponding 10 points DFT is yk. Now, you are asked to determine y0 and y5. So first of all, you can write down yn with different values of m in sequence. So since k is 0 for y0, then the exponential term is 1. So now, when you sum up yn from n equals 0 to n equals to 9, then you will get 70. And then for y5, you are replacing n with the values from 0 to 9. And after summing those values up, you will get y5 equals to 0. And that'll be all for the problem 2. Thanks for watching.